All right, if you can hear my voice, clap once. If you can hear my voice, clap twice. All right, so go ahead and make sure your math journal is in front of you, okay? And we're gonna go ahead and put our worksheet to the side and make sure you have your pencil as well, all right? So today we're gonna be continuing our unit and measurement, okay? The metric system. We're gonna start out today with an activating strategy, okay? We're gonna watch a little song here on YouTube to start our lesson. You can sing along if you like, because I know some may know it. All right.
A millimeter you can understand is about as long as a grain of sand. When you buy food at lunchtime, it's about the thickness of a dime.
A staple from side to side is about a centimeter wide. A fingernail on a girl or guy is about a centimeter high. 10 millimeters, a centimeter, 100 centimeters is a meter, 1,000 meters, that's a kilometer, and it's the same for grams and liters.
A school bus with diameter is about 1 meter, and a meter is about as far as the length of a guitar.
And soccer fields in a row, about a kilometer will go. It's about how far you walk, and it goes 12 city blocks. 10 millimeters, a centimeter, 100 centimeters is a meter, 1,000 meters, that's a kilometer, and it's the same for grams and liters. Imagine holding a grain of sand, or a marble in your hand, a short hand from the floor, a 10-minute walk on the shore. 10 millimeters, a centimeter, 100 centimeters is a meter, 1,000 meters, that's a kilometer, and it's the same for grams and liters. 10 millimeters, a centimeter, 100 centimeters is a meter, 1,000 meters, that's a kilometer, and it's the same for grams and liters.
All right, awesome. So, again, the purpose of us watching that video is because, again, I want us to be thinking about the importance of measurements, okay? Because in third grade, you guys were somewhat introduced to certain measurements and trying to find their equivalents to one another, okay, and how they work together, okay? So, let's go ahead and get into our I can statement. Okay, who wants to read for me? Aeon.
I can use the four operations to solve problems involving metrics.
Awesome. You can solve 4 operations to solve problems involving metric measurements. What stands out to us? Woo.
Four operations.
Okay, the 4 operations. What else sticks out to us? Amalia.
Solve the problem.
To solve problems. What else sticks out? Hazafa.
Measurements.
Measurements. Well, what kind of measurements?
Metric.
Metric. Awesome. Let's go ahead and talk about it. So, what are the 4 operations? Who can give me one? Valentina.
Division.
We have division. And what kind of key words are we going to see in word problems to let us know maybe we should divide? Allie.
Equal groups.
Equal groups. Awesome. All right. So, what's another operation? Let's see. Jasmine. Multiplication. And what key words or phrases will we see to know that we have to multiply? Whoa.
Each.
Each. Okay. Or even times, right? What's another operation, Zoe?
Subtract.
Subtraction. And what key words will we see to know that, okay, this problem is wanting me to subtract? Kaylin?
Add.
That's another, yes, that is another operation. But Ms. Bush is asking, what key words will we see in a word problem that will let us know they're wanting us to subtract? Leilani?
How many?
How many more? Good job. Difference, I heard somebody say that. So how many more? We may see difference in there. Left in there, okay. Okay. Thank you. Y'all are showing out. Awesome. All right, so the last one Kaylin said, which was add, right? So addition, what words or phrases will we see to know that this problem is wanting me to add? Ibrahim?
Altogether.
All together. What else? Is there one more? Aeon. In total.
Some.
All.
All.
Awesome. All right, so solve problems involving metric measurements. So let's go ahead and talk about metric measurements. What kind of metric measurements have we talked about so far? Hazafa.
Centimeters.
We talked about centimeters, so I'm abbreviating them. Jennifer, give me one. Millimeters. Paimon. Kilograms. All right, one more. One.
Kilometers.
Okay, and kilometers. No. Let's do meters. Okay? That we mentioned so far. All right, so let's go ahead and go into our essential question. So, why do you think it's important to be able to express larger units in terms of smaller units within the same measurement system and smaller units in terms of larger units within the same measurement system? Okay? So, as we're going through today's lesson, I want us to be thinking about what's the connection between larger and smaller units, okay? So, let's get into the lesson. So, it says the top shelf on Sean's bookcase can hold a minimum of 5,000 grams. The picture frame and the plants have a total mass of 3 kilograms and 245 grams. Sean wants to add 2 vases to the shelf. What is the greatest possible mass of the 2 vases in grams? Okay, so first thing is first, this is the word problem, so we must look for what we know, okay? We gotta look for what we know. I know, okay, that his bookshelf can hold, or his bookcase can hold a minimum of 5,000 grams. What does that mean if it can hold a minimum of 5,000 grams? Hazafa?
That's how much it can hold.
That's how much it can hold. It can't hold no more than that, okay? And I also know in my problem that I have a total mass of 3 kilograms and 245 grams. So what I noticed is that I'm dealing with 2 different metric measurements. The first metric measurement that I'm dealing with is kilograms, and the second metric unit that I'm dealing with is grams. Okay, so they're different. So because they're different, I must make them equal, okay, in order to solve the problem. So, starting with the first part that I need to figure out, because this is a multi-step problem, okay? Because in order for me to figure out to figure out the greater possible mass, I need to figure out how to make them equivalent first, okay? So the picture frame and the plants have a combined mass of 3 kilograms and 245 grams. What is the combined mass of the picture frame and the plants in grams? So again, I have to make them equivalent. So I'm gonna make me a lovely T-chart, okay? So on one side, I have my kilograms. And then on the other side, I'm going to have my grams, okay? Who can remind me how much is 1 kilogram? Aeon. 1,000, okay? So that means that 1 kilogram is equal to 1,000 grams, okay? So, how many kilograms does the problem say I have? I have 3. So I'm going to go 1, 2, and 3. So I have to convert these 3 kilograms into grams, okay? So going back to our I can statement about using the 4 operations, I can easily do 3 times 1,000 is going to give me G for the total mass of grams, okay? Because again, each kilogram is 1,000 grams. So that means that 1 is going to be 1,000, 2 is going to be 2,000, 3 is going to be 3,000, okay? So 3 times 1,000 is 3,000 grams, okay? That is the first, oh, let me forget my G, sorry. So G equals, because you guys have to remember to bring your metric measurement at the end of the solution. So G equals 3,000 grams, okay? That's the first part of my problem, okay? Now going to the second part of my problem, it says Sean wants to add the vases to the shelf. What is the greatest possible mass of the 2 vases, okay? So remember, the total shelf can hold a total of 5,000, right? 5,000 kilograms. So I'm going to take what I have. So let's imagine if I had a bar model. So if I had here the frame and vase all together. Altogether, the frame and vase, okay, is 5,000, right? But I'm trying to figure out X over here for the possible mass of the 2 vases. So the whole thing can hold 5,000, but I'm trying to figure out X. And what I have so far is 3,000 grams, right? But I also have 245 grams. So before I can even figure out the possible mass, I need to add my 3,000 to the 245 grams that I have, since now I made them equivalent, right? So now I'm going to do 3,000 plus my 245, which is 3,245, okay? So now I'm going to take that, because this is what I have, and because I'm trying to find an X, I'm now going to subtract the total of that it can hold to what I have to see what he can do, okay? So that's the next part of my problem. So my next equation would be 5,000 minus what I have is going to equal to the grams, okay? So a new strategy that I introduced was how we can do number compensation, okay, to subtract. Because again, we have so many zeros, and let's not take all that time to regroup, right? We can simply just go down 1 from 5,000, and that's going to give me 4,999, right? So now I'm going to take that and I'm going to subtract it from my 3,245. 9 minus 5 gives me 4. 9 minus 4 gives me 5. 9 minus 2 gives me... What does 9 minus 2 give me?
7.
And then 4 minus 3 gives me... 4 minus 3 gives me 1. Okay? So, Sean, okay, can overall use, or Sean overall has 1,754 grams, okay? That means that whatever he wants to put on the shelf, it can't be no more than 1,754 grams, okay? So again, this was very multi-step. The first number of operation I had to do was I did what? What was the first operation I did to find the equivalence to kilograms to grams? Zach?
You measured them.
Not I measured them. What was the first operation? 4 operations. Val?
Multiplication.
I multiplied. I had to multiply first, okay, to get them equivalent, okay? 3 times 1,000, which gave me my 3,000. After that, what other operation did I use? Aeon. I use subtraction to figure out how much he has in order to put on his shelf. How many grams the items can weigh in order to put on his shelf. Okay? So now, we're going to see our I can statement again. Somebody read it to me. Lay.
I can use the for operations to solve problems, including metric measurement.
Yes, you can solve the 4 operations. You can use, the 4 operations to solve problems involving metric measurements, okay? So now it is your turn, okay? Again, look for what you know about the problem, okay? And think about what operations you are going to use, okay? So I'm gonna read it to you. It says, Ashley mixes 500 millimeters of honey with 4 liters of tea. She distributes the sweetened tea equally into 5 containers. How many millimeters of sweetened tea is in each container? Look for what you know. It looks like we're dealing with 2 different metric measurements. So there's something that you have to do first in order to solve the rest of the problem. All right, go ahead and get started. I'll be walking around. I'm gonna give you about 3 minutes to do it on your own, and then you're gonna collaborate and share strategies with one another. Oh, I'm sorry. There you go. All right, I want to see everyone working. I'm walking around. Good, you're on the right track. Good, you're on the right track. How many liters are we converting? So now what do you have to do with that? Okay. Give us about a minute. All right, come on. How many are you converting? It says that 1,000 milliliters equals 1 liter. So you're really converting these to these. And how many of those do you have? How many of these do you have? Where's the problem there? Exactly. 1, 2, 3, 4. You're converting those to that. Look at the conversion. 1,000 equals those. What are you converting? Read your T-chart, please. Okay, so what are you converting? You have 2 different measurements. Yes to what? Exactly. And how many of those are you converting to that? How many of those do you have? Okay, so you need to convert 4. Good. All right, you guys go ahead and collaborate with one another, share each other's strategies. Let's see what you and your friends are, if you guys are on the same track. Share strategies with one another. Okay, good. So,
And then
what? I don't see how. Did you add the other milliliters?
yes, so I added them.
That's before you get to this step. Though, what do you have to do with this? Add it to what?
After that,
Yeah.
I divided them.
I want to see the
And
step.
9 and I'll
So I know that you.
So you bring the 5 over 45. And then 45
Good.
divided by
Okay, good.
9 times 5 is 45. So I put the 45 there, and then I minus it, and then I put it in the pen. Awesome. Nobody goes, so I put 0 there.
Awesome.
Sounds good.
All right, let's bring it back in 5, 4, 3. Awesome. So definitely be checking your work. I walked around and everybody pretty much did a great job. So we know that Ashley mixes 500 milliliters of honey with 4 liters, right? So because I'm dealing with 2 different metric measurements, what do I have to do? Val.
Make a T-chart for both of the
Measurements. Yes. So what am I converting? What will go here? Zoe. Liters and milliliters. Okay. How many liters did she have? Steven.
4.
She has 4. So that means for liters, I'm going to go 1, 2, 3, 4. Right? Well, what is my equation going to look like? What is my equation going to be? How's that look?
4,500.
What is my equation going to be? To convert liters to milliliters, what is my equation going to be?
For the first one?
For the Yes, what is my equation going to
1
be?
times 1,000.
Yes, it is going to be 1 times 1,000, right? But what is my overall equation? What is the overall equation going to be? Aeon. 4 times 1,000. Okay? It's going to give me my milliliters, okay? So I know that 4 is going to be converted to 4,000 milliliters, okay? You know that, yes, that's 1,000, and as you go on, you know when you get to 4, it's going to be 4,000, okay? But what is my next step going to be? Now that I converted my liters to milliliters, what do I have to do next, Ibrahim?
Add 500 milliliters.
Add the 500 milliliters that I already have to this 4,000, so that's the first part. So now my second part is now I'm having to add 4,000 plus 500 is going to equal my total combined, okay, of the two, which gives me what, Paimon? 4,500. Awesome job, but am I done? No, I gotta go even further because the next part asks me or tells me, right, that she distributes. If I go back to the oh, I'm ahead of myself. We said equal groups. But if we know when we see the word distribute, what operation are we using? Distribute? Division. I'm distributing because I want to distribute it into 5 equally into 5 containers. So I want to distribute 4,500 milliliters of tea into the 5 containers. Okay? So yes, I am now going to be dividing. Okay? So my equation now is 4,500 divided by 5 is going to give me my milliliters. Okay? Here's another trick strategy, right? You may say, oh my goodness, that's such a big number. 4,500 divided by 5. Oh no. But what can you do when you have zeros? You can always cover it up. And you can just say, well, what is 45 divided by 5? Who can tell me? Joel, what is 45 divided by 5? 9. And all I have to do is just drop and bring over those zeros. Okay? Milliliters. So, how many milliliters of sweet tea is in each container? 900 milliliters. Okay? So again, going back to the eye candy operations, in this problem, we use multiplication and division. Awesome job. All right, so definitely check your work. Is everyone good? I can erase? All right.
Yep.
So now you're going to go ahead and you're going to pull out the worksheet that you have out. We're going to work on the first 2 together again. We're now going to be talking about a whole bunch of lovely paper clips. And we're gonna continue to work on our conversions, our measurements, okay? So, let's look at this. Whole lot of paper clips, okay? So, starting out, it says that one paper clip weighs 1 gram. So, number one says, how many grams are the paper clips in each image? Let's look at A. Somebody count how many paper clips do we have here? Emilio? 7. And if I know that one paper clip weighs 1 gram, what is my total? Allie?
7 grams.
7 grams. B tells me that I have how many paper clips to weigh? 100, right? So how many grams do I have, Kaylin? 100. Awesome. C tells me I have how many, Amalia? 250. So that means how many grams do I have? Joel? 250. Awesome job. Do we see that?
Yes. Got it.
Awesome. Okay. Now this is going to be the last one we work on. Or what I want you to do is you're going to work with your elbow partner and you guys are going to work on number 2, okay? And then we'll come back together. Go.
I already did it. I'm trying to go with
You can work with Zoe. Your row. Your row is fine.
It's 1,000 equals to a kilogram. Okay. What's a kilogram? Picture.
Make sure you're showing your work. How'd you know it was this? That is true. But also there's 5, right? In each pack, right? And 500 is 500 is going to give you that 1,000, right? Okay. You finished? Alright, awesome. What's wrong?
Look.
Okay. Alright. 1 more minute. Okay, awesome.
5 boxes.
50. If there's 100, 100.
That's my pencil.
Okay. Leilani. Okay, it's fine. I'll give you. All right, let's bring it back in 5, 4, 3, 2. All right, so the paper clips in this image weigh 1 kilogram, okay? So let's look at this. How many paper clips do we have? Yeah. 500 in each of these, right? So box 1 or case 1 has 500. Box 2 has 500. And when I add both of these together, what does it give me? Oh, I'm sorry, I was about to give you the answer before I tell you to me. Zach.
5,000.
5,000?
1,000.
1,000, it's okay. And what do we already know anyway about 1 kilogram? That 1 kilogram equals what? Kaylin?
1,000.
1,000. We know that already, okay? Awesome job. So, go ahead and check yourself. All right. Pencils down. Papers down. Pencils down, papers down. One. Thank you so much, Zoe. So now let's reflect over everything that we've just done, okay? And we're going to come back to our essential question. Why do you think it's important to be able to express larger units in terms of smaller units within the same measurement system? And smaller units in terms of larger units within the same measurement system. So why is it important to be able to express larger units and smaller units? Why is it important within the same measurement system? Why is it important for you? Think about it. You did kilograms and 2 grams. Out of those two, which one is the larger unit? Aeon. Kilograms. Which one is the smaller unit? Grams. So why do you think it's important? Think about what do you want to do with these two? What's important to know what to do with these two, even though they're two different measurements? Allie? Yes, you do measure kilograms with larger objects and grams with smaller. But what do they both have together among you? What is important to know? What can you do? Yes. Yes. But going back to the problems, y'all, what were we doing with those two different metric measurements? One was always bigger than the other, or one was smaller than the other, and what did we always have to do with them? It's important to know how to make them what? How to make them equivalent, okay? Knowing how to make them equivalent, because sometimes, think about it, if you're at home and you're trying to make some cake or something, and you may not have the right measuring cup, you can always think, well, what would be equivalent to a 1/4 cup? I know we're not there yet, but a 1/4 cup will be equivalent to a 1 ounce. Does that make sense? All right, awesome. So now we are going to do our closure, okay? It's going to be a stick-it. You're going to stop it, get you a sticky note. If you don't have one, I will give you one. You're going to write your name on the back, and you're going to stick your answer to the board, okay? Before we get started, I do want you to know that tomorrow we're going to go a step further, and we're going to be talking about time, okay? Time, okay? Time. Yes. You need a sticky note? Yes. I'll give you one. Yes. Anyone else need a sticky note? So again, you're going to stick your answer on the board, okay?